Hi, I'm Mr. Baker, and these are the notes for Unit 2, which is the chemistry of life, or biochemistry. Atoms, ions, and molecules. Atoms are the smallest particles of matter that have distinct physical and chemical properties. Each different type of atom makes up an element, and they have on the periodic table their own designation. Also, never trust an atom. They make up everything. Atoms are comprised of protons, which are found in the nucleus and carry a positive charge. V for positive, P for proton. They identify the identity of the atom, and they also is the atomic number. Neutrons are found also in the nucleus. They have no charge. You add protons and neutrons to get something called the atomic mass. Electrons are found circling outside the nucleus. They are negative, and the number of electrons usually is equal to the number of protons. There's a YouTube link there for a really cool thing from a sitcom way back in the late 70s, early 80s that tells you the story of Atom, including 3 gangs called the Pros, the New Boys, and the E-Boys. The atomic number, the element symbol, the element name, the atomic mass. You should be able to read a periodic table. You do not have to memorize a periodic table. We will give one to you. I do expect you to know the most common elements found in living things, and there are 6 of them that you're responsible for. And there they are. Sodium, chlorine, potassium, and calcium are found in small amounts and are called trace elements. The 6 I expect you to know, you can remember with the silly word chomps, which is kind of like chomps, like eating, because these are things that we need. C for carbon, H hydrogen, oxygen, nitrogen, phosphorus, and sulfur. You need to know the difference between a molecule and a compound. A molecule are just 2 or more atoms joined together. A compound has 2 or more elements. H2O, compound. O2, molecule. All things are joined together with chemical bonds, and that involves giving, taking, or sharing electrons. There are 2 main types of bond. Ionic, which you're going to give and take electrons. The example is salt. And covalent, which is a sharing electrons. But you don't always share equally. If you do share equally, that's called a non-polar covalent. The examples are fats and oils. A polar covalent bond means you are unequally sharing, and the great example is water. Anytime that you have lost or taken an electron, or given or taken an electron, you are then called an ion, and that's the point of an ionic bond. They have given or taken an electron. There's a nice picture. Polar covalent bonds, again, unequal sharing. And that means if you share unequally, one side of the molecule is going to have a slightly positive charge, and the other side of the molecule is going to have a slightly negative charge. In the case of a water molecule, an easy way to remember it, although it's not completely accurate, is that it looks like Mickey's head. The face is negative, and that's the oxygen. And ears, those are the positive part of the molecule. Those are the hydrogens. These hydrogen bonds only can happen when you got a polar. They are a weak bond. They are not very strong, and you can find them in pretty much everything, DNA, proteins, and water. And they look like here the Mickey Mouses are attaching themselves. So ears to face to ears to face. That would be time for your quiz over section 2.1, but I'm going to go ahead and do the next section in our notes. 2.2, the properties of water. Because water does these hydrogen bonds, it can do all of these important properties, and there are 7 of them. So let's get into them. Adhesion, water molecules, because they hydrogen bond, they can stick to other things, like the inside of a straw. Or cohesion, where water will stick to itself. Adhesion, other things, cohesion, itself. Water exhibits something called surface tension, and that at the surface, at the interface of the water and the air, all the water molecules are bound to one another, and they hold each other together, creating surface tension. These are exploited, as you can see in the picture there, by an insect called a water strider, where they are actually pushing down on the water and forming a little indentation. But these are insects and not spiders. They are water striders. There's a lizard called the Jesus lizard that doesn't actually walk on water, but with surface tension, it actually makes pockets of air, and it can run at pretty at a pretty good speed across the water using those air pockets and the surface tension. Capillary action is when water climbs up a straw, and that's because water will stick to the inside of the straw, and then as it moves up, it can overcome gravity and pull cohesion water molecules with it. So cohesion, they'll stick to each other, and adhesion, they stick to the wall of said straw. That's capillary action. It's also the reason why paper towels soak up water. Because of cohesion, the water molecules stick to each other, and adhesion, they stick to the fibers in the paper towel. Water has a high heat capacity, meaning that it takes a lot of energy to raise the temperature of water, and the old phrase is boiling. A watch pot never boils, meaning it takes forever and ever and ever to have enough energy to get water to boil. Another nice picture. You need to know the states or phases of water. Water density is listed from most dense, which is heaviest, to the least dense or the lightest. Liquid is the most dense, and that's at 4 degrees. Solid, ice flows. Ice will float, which is why we can go ice fishing. And back to ice fishing in a second. And gas is the least dense. These are water vapor or clouds. All of these come together when we talk about ice fishing. You can walk on the surface of a lake, drill your hole so you can go ice fishing. So you're using the solid phase of water. The liquid is the most dense at 4 degrees centigrade. So if it's winter, it's very cold. If you've got ice, it's below freezing, which is below 4 degrees centigrade. And the fish will move to where the warmest water is, which is 4 degrees centigrade, which is why when you go ice fishing, you take your tip up and you drop it all the way down to the bottom and then pull it up about 12 inches. So you're right above the bottom of the lake, and that puts your bait right in the middle of that 4 degrees centigrade where the fish are there because it's the most warm. Water is also a good solvent, and it dissolves things because it's polar. You need to know the difference between solute and solvent. So in the example of sugar water, Kool-Aid, the solute is what is getting dissolved, that's the sugar, and the solvent is what is doing the dissolving. That's the water in that case. I made a nice table that has the cohesion, adhesion, and all of the properties of water, which should be on your topic page. Osmosis is the diffusion of water across a membrane. Water will move freely in and out, and they will move from areas of higher solute concentration to an area. Strike that. Water will move from an area of lower solute concentration to an area of higher solute concentration. The concentration is how much stuff you have. That is a concept I want you to know. For example, salt water has a lot of salt in it. Saline has a little bit of salt in it, and pure water has 0 salt. So have an idea of what concentration means. There are 3 types of solution. Isotonic. This is a solution that has the same concentration of the amount of stuff. Where do the water molecules move? Iso meaning same. So water molecules do not move one side or another. We'll have more about this later in the next unit, and it'll make more sense. At least it does to me when I teach you about something called psi. Hypotonic solution has a lower concentration. There's an O in hypo. There's an O in lower. This is how I remember it. Where do water moves? The number of water molecules entering the cell is far greater than the number of water molecules leaving. Cells expand, or what is pronounced lyse, and that means they break and they go boom. O for hypo, O for lower, O for boom. Though that if you put cells in a hypotonic solution, boom. The last solution you'll need to have memorized is hypertonic. R in hyper, because if you look down at the bottom, the cells will shrink. The solution has a higher concentration amount of stuff as to the cell cytoplasm. So where do the water molecules move? They move outside of the cell. The cell loses water, they shrink or crenate. So hyper has an R in it, so does the word shrink, and so does the fancy word crenate. And that finishes quiz 2.2, the properties of water and the 3 different tonics that you'll need to memorize. Study hard.